Well, good morning. My name is Dwayne Brown from NASA's Office of Communications at NASA headquarters in Washington. Thanks for joining us. In this last briefing for today, NASA's senior leadership will give their views and comments on how MAVEN and other NASA mission and activities in the agency's exploration portfolio are paving the path toward a human mission to Mars in the 2030s. We'll have brief presentations and remarks from our participants. Then we'll open it up for questions here at the Kennedy Space Center. As always, you can get updates on the MAVEN mission online at www.nasa.gov/MAVEN. And of course, join the conversation on social media. And when it comes to Mars, there's always a lot of conversation on Twitter, Facebook, and other social media venues. Let me start by introducing our participants, and I'll start here at the Kennedy Space Center. First to my left, someone who's very familiar with the Kennedy Space Center, 5-time flown space shuttle astronaut, astrophysicist, and the Associate Administrator for NASA's Science Mission Directorate, John Grunsfeld. The Associate Administrator for Space Technology Mission Directorate, Michael Gazurek, and a footnote here, the agency realizing the importance of space technology, it elevated the Space Technology Program into a new directorate in February of this year. Michael Gazurek, Associate Administrator. And NASA's new Chief Scientist, starting in the position August 25th, Ellen Stofan, the Principal Advisor on the agency's science programs and science-related strategic planning and investments. And joining us from our NASA studio in Washington, D.C. at headquarters, the Associate Administrator for NASA's Human Exploration and Operations Directorate, William Gerstenmaier. And with his portfolio with ISS, Orion, SLS, and commercial, a lot of good things are happening on that front. And to hear from him and the things and the synergy between science and humans, I'll toss it to Bill in Washington. Bill, the floor is yours.
Okay, thank you, Dwayne. Can I have my first slide, please? On this graphic, we talk about kind of as we push humans beyond low Earth orbit, really out into deep space. So, you know, where we are today with the International Space Station, we have a crew of 6 on board the space station doing a lot of research that benefits us here on the Earth, but they're also doing a lot of activities that are really preparing us to go beyond low Earth orbit. You know, just the fact that we have humans there for an extended period of time, we're understanding how the human body reacts in the microgravity environment. So on missions on the way to Mars and of that duration, we need to know how the human body actually adapts to that environment, and are there any unique special needs that we need to take care of the crew. So we're understanding how the crew operates and lives and works in that environment on board space station. We're also using the space station to develop technology that's needed to last a long duration. We need systems that are tremendously reliable, require low maintenance, and ready to move those kind of distances as we start breaking the tie with the home planet. In that middle region, we talk about kind of the proving ground, and what that is that's moving out into cislunar space. It's the asteroid redirect mission. It's those kind of activities where we're starting to break the tie from the home planet, from Earth, but yet we still have the ability to get back in several days to the Earth if something goes wrong, or if we have equipment that needs some different activities. We also need to operate or learn how to operate from an orbital mechanics standpoint in that region. And then finally, when we get out distances as far as Mars, we really need to break that tie back to Earth. So at that point, we need to be independent from the Earth. We need to understand how to use the resources of the environment where we are, where we're at. We need to carry with us all the supplies we need from Earth and the ability to essentially use in situ resources, or essentially live off the land in those remote locations. The MAVEN mission, which we're all here for today, or you're all there for today down at Kennedy, I wish I could be there with you, but I'm not. I'm here in Washington. But the MAVEN mission will provide some interesting information for the scientists, and John will talk about that, but it's also good information for us kind of on the human spaceflight front to understand how the atmosphere of Mars is put together, what the upper atmosphere is like, what the mid-level atmosphere is like will be important as we look at entry, descent, and landing into the Martian atmosphere with larger spacecraft than we've done before, the kind of spacecraft that will be needed for human missions. We'll also understand what resources are available in the atmosphere, and can some of those resources be used as a tool for human exploration. So again, science is kind of proving the way or pushing the way forward. We'll take the data from the scientific investigations, use those on the human side, as well as understanding the basic science activities that are occurring around Mars. So again, I think I'm looking very forward to this MAVEN mission. The data will be important to us on human spaceflight, and it also fits well with the science activities going forward. So with that, I'll turn it over to John down at the Kennedy Space Center, and he'll continue on with the discussion of the MAVEN and the science activities. John?
Thanks, Bill. So of course we're here for the MAVEN launch, and I'm excited to see it go off tomorrow, hopefully not any later than that. And you know, MAVEN is a science mission, but none of our missions are really can be characterized as just science missions. All of our missions are human missions in the sense that, you know, it's the science teams that are going to be analyzing the data. And, you know, if you ask, you know, Bruce or any of the team, they're going to Mars tomorrow. And I'm very excited about that. As a human spaceflight flyer, I would love to be on board with MAVEN. In fact, I drove by Complex 41 to see if there's any way I could sneak aboard, but they have it all blocked off now. So we don't just launch science missions to Mars one at a time. We have an integrated program of Mars exploration. We've been following a path of looking for water on Mars. Of course, we've known for decades there's water on Mars, but looking for current water, past water. Now we've confirmed that Mars once was a warm, wet planet, had flowing water, Curiosity, warm, salty seas, Opportunity, Phoenix, which landed on a glacier, an active block of ice, water ice. And so we're transitioning into the search for biosignatures of past evidence that life could have started on Mars, and we don't have that answer yet. And that's all part of our quest for trying to answer, are we alone in the universe in a much broader sense? And I think Ellen will touch on that later. So MAVEN's not just one of a kind, it's part of an integrated portfolio, and I have a short video that I'd like to show that just kind of lays all of that out so that you have some perspective. So we have the Mars Odyssey spacecraft, we have the Mars Reconnaissance Orbiter, the Opportunity, Phoenix, and of course the amazing Mars Science Laboratory Curiosity rover. MAVEN in 2016 will launch the InSight mission, which will be a geophysical monitoring station to the surface of Mars. We've looked at we will have looked at the atmosphere with MAVEN, the surface with the rovers and the orbiters, but we won't have looked into the planet. So that's what InSight will do. In 2020, we have the Mars follow-on rover, which will not only have science, but for the first time we'll have a major payload that will be both a technology and a human spaceflight in situ resource utilization experiment. And I look forward to a time when we can have humans on the surface. The odometer on Curiosity reads around 420 meters or so, probably a little bit more. Sorry, 4.2 kilometers. 4.2 kilometers. I think John Grotzinger could probably do that in about a day. Maybe not quite all of the analysis, but he'd be going to the hot spots and collecting samples and bringing them in. In order for us to get there, though, we need a lot of technology. And as I said, the Mars 2020 announcement of Opportunity just went out recently, and it's a joint announcement of opportunity for experiments and experiment packages between human spaceflight, science, and technology. There's no question that to get those women and men on the surface of Mars, the astrobiologists, the planetary scientists, there's a lot of technology that we still need to develop, to mature, so that we can get humans to Mars. I'm looking forward to that day. Unfortunately, it turns out we didn't get there fast enough for me, but Mike Gazarik's working on the technology to enable our future explorers to get there. Mike?
Thanks, John. Well, again, it's great to be here. Really excited about tomorrow's event. Well, I could never be qualified to climb in it. I as an engineer, would love to have hardware in it. And well, we don't have hardware on this particular mission on MAVEN. From a space tech perspective, in my years in engineering, I certainly have. I can really relate to those teams, having hardware on the Mars Science Laboratory, and having hardware on the International Space Station used by astronauts. I remember that exhilaration, right, when it was actually Pierce Sellers, the astronaut, turning on the camera for the first time. Would it work? Would it not? In mission control. I remember the excitement on the landing of Curiosity, leading the project to put instrumentation in the heat shield as we learn how to fly through that Martian atmosphere. And as the one who advocated, in essence, to put holes in that heat shield, I can tell you I was as nervous as anybody that night. And I really relate to the great folks at Maven, and congratulations to that team and the hard work it takes. You know, these high-energy events, all that years of work really comes down to these very black and white events. You know, will it work? Will it successfully get off? And we know it will tomorrow, and we're really excited about that. I want to talk a little bit about technology. As John mentioned, you know, it's a big part of our exploration in the universe. You know, we don't want to just survive in the solar system. We want to thrive in it. And to do that, we know we need a number of things. You know, Bill mentioned the heavy lift launch vehicle and a human-rated capsule. But there's also a whole host of technologies that we know we need to get to Mars. Do we know we need to allow humans and other future robotics missions to get to Mars? And we know this for a number of reasons. We've had a lot of studies over the years. Yeah, in my office alone are 40 reports that have been done over 20 years, all laying out what are the things we need to do to get to Mars. And so finally in space tech, we're not studying as much as we're really getting to it. And to kind of take you through that, I have a short 2-minute movie on this. Now, I will warn you, it's a quick movie. I showed it to my wife, and she thought it was very, very, very quick. I showed it to my children, and they loved it. So you can judge yourself and your generation on whether or not you think it's kind of quick or not. But if we could roll that video, I'll kind of take you through it and talk a little bit about the technology.
By the mid-2030s, I believe we can send humans to orbit Mars and return them safely to Earth. And a landing on Mars will follow.
So just a quick historical perspective, and not to go through it all, but starting in 1964 with Mariner 4 and some of our first imagery up close of Mars. The Great Viking missions in the 70s, both 2 spacecraft landing on the surface of Mars. And then, of course, Curiosity landed a little over a year ago, August, and the incredible results we're getting. A metric ton on the surface of Mars. But here are some of the challenges and the questions if we're going to go there in earnest. More than a metric ton, right? More with humans, more with the spacecraft and the cargo that we need. And how about a place to live and a habitat to live? So those are just some of the challenges. And what we're going to talk to you about now is some of the things we're working on to get us there. And we're working and flying and testing those technologies today. So here are 8 quick areas that we look at from a technology perspective about getting to Mars. And we'll just kind of walk through quickly and show you some of the hardware and the folks that are working on each of these areas. Communications and navigation, optical comm. We just demonstrated coming off the moon and LADI, 622 megabits per second. Most of the images we take of Mars remain on Mars. We need to have that optical pipeline to get them back to Earth. It's all about transportation. How fast can we get there? And the use of cryogenic propellant, the ability to store that propellant, high-power solar electric power are all keys to getting to Mars. Once we get to Mars, how fast can we slow down? Can we get 20 metric tons safely through coming in at 11 kilometers a second and have 7 minutes to get to 0? Can we land on the surface? We all know it's about humans and robotics. We already have R2 on station. We already did the first telerobotic operation from the International Space Station. It's humans and robotics. The radiation challenge is significant for humans. We're looking at a number of ways to protect the crew as they go to and from the surface of Mars. Life support. We have to enable high, reliable life support. Even Apollo 13, it was 84 hours that they had to be able to survive. Well, we need to turn that into days, into weeks, to be able to ensure the crew remains safe. Once we get to the surface, we need power, whether that be from nuclear or high-power solar electric, to be able to operate and thrive on the surface. And then finally, can we live off the surface? And on Mars 2020 will be one of our first demonstrations on the 2020 rover, converting carbon dioxide to oxygen, and kind of pave the way then for using the resources that Mars offers. So that's really the technology, a quick snapshot of some of the technologies we're working on. And just behind, like behind Maven, it's really the people that are behind it, and the people doing the work and are out in the field today, developing and flying the technologies we need to get to Mars, and that's really key for us. The technologies we have, by the way, are relevant to Mars as well as any really destination in the solar system. It includes more than Mars. It's our ability to thrive in deep space. And so that's a quick summary of some of the technologies in Mars. Ellen, I know, is going to talk a little bit about some of the other surfaces and planetary destinations, again, that these technologies will enable. Ellen?
Well, John talked about the overall integrated program of Mars exploration, but really all of the science that we do at NASA is interconnected. Really around the fundamental question of how did we get here? What are the origins? How is the solar system, our own planet, how is it changing and evolving? And ultimately this big question of, are we alone? From everything that we're doing at NASA, from within the solar system, we have our Mercury mission MESSENGER to the Cassini mission at Saturn. Those missions are really getting at how do planets form, how do they evolve. We have Earth measurements at NASA where we're studying our changing climate and trying to understand better how fast it's changing and how it's changing. We have missions that are not just thinking about planets in this solar system. We've had in the last few weeks these amazing results from the Kepler mission where we've now at up over 3,500 planets that we've found, some of them in that habitable size range that we're so interested in. And those results from Kepler have really literally rewritten the textbooks on how we think solar systems form. And, you know, keep your seatbelt fastened because I think the discoveries still coming out of Kepler are really exciting. And then you look beyond that to what we're doing in planetary, from the Juno mission, which is on its way to Jupiter. We have the New Horizons mission on its way to Pluto, and OSIRIS-REx, which is going to go after an asteroid. So we have an exciting range of missions coming up. And while, again, they may seem like discrete measurements, asking discrete questions, they're really getting back to this fundamental issue of how did our solar system form and evolve, and are we alone? And I think that was really poignantly brought out just this week. We released, which I'm sure a lot of you have seen, this amazing image from Cassini that was taken looking back at Earth, showing this pale blue dot that Carl Sagan spoke so eloquently about. Really getting at, again, this question of we're this fragile little planet out there in this big solar system. And yet we have the tools, we have things that we're developing like JWST that are actually going to be looking at the atmospheres of planets around other stars, and then we can even use that tool to look into our own solar system to study Uranus and Neptune. We're doing exciting things at NASA, and they're truly interconnected as we try to understand the answers to these basic questions. Like everybody else, so excited to be here for MAVEN. I was realizing when Mike showed that video, the last time I was here for a Mars launch was Viking, so I'm afraid that dates me. Yeah, I was 2, I think. No, I'm just kidding. I was a lot older than that. But MAVEN is really getting, as John talked about, at this issue of how do we follow the water? You know, how did Mars evolve differently from the Earth, and did life evolve on the surface? MAVEN is really a critical puzzle piece in answering that question, trying to understand those processes that are taking place at the top of the atmosphere. But again, it's very integrated in everything that we're doing. I'm a geologist, and I've spent most of my career out in the field picking up rocks, and so I have this incredible bias that it is really going to take future astronauts, field geologists, astrobiologists at Mars, picking up those rocks, doing the field surveys that geologists do here on Earth, taking our science not just from doing remote science like we do now, but doing science on the ground that's really going to help us get at this question of, are we alone? So I'm excited about looking forward, looking towards that human exploration of Mars, because I think it's really going to revolutionize our science in the end. And with that, I will turn it back to Dwayne.
Thank you. Okay, as always, please wait for the mic and give your name and affiliation, please. And let's see who we start here in the front.
Hi, Ken Kramer for Rocket STEM and Universe Today. Bill Gerstenmaier, I have a question for you and maybe also for John. I'd like to know about the ISS. Talking about getting the humans to Mars, I'm wondering about the extension of the ISS. It's key to get these technologies developed. You have spoken, I believe, about getting a decision perhaps in 2014. Can you talk about that process? How does it look, and what would happen if the ISS was not extended? Thanks.
Thanks. You know, we've been working with the administration and bringing forward our ideas on extending the space station. You know, we've laid out kind of in a matrix fashion what I talked at the beginning of my opening remarks. I talked about the things we need to understand how the human performs in a microgravity environment. We can get a lot of those things completed through the lifetime of station through 2020, but some of those items we would really like to have some more activities beyond 2020, and we've made some cases for those. Also on the technology side, there's some technology that we will have demonstrated to a certain level by 2020, but going beyond 2020, we can really complete those more. So I think we've built a pretty compelling case from an exploration standpoint of why station needs to be or should be extended, and we'll continue to work that with the administration as we go forward. You know, we're looking pretty forward and pretty excited about the 2015 mission, where we'll have a crew on board station for 1 full year, and that's a chance to really see that is there anything that happens to the human body beyond the 6-month period in microgravity that is really of consequences to us as we contemplate a Mars journey and those kind of destinations and those kind of distances and time frames. You know, the Russians have done it before. We've had humans go beyond the 6-month period, but we've got a lot of tools now. We can really understand how the body really performs and how it's really changing to make sure that we're really prepared to go do those kind of durations it'll take to take humans to the surface of Mars.
I think from a space tech perspective as well, the International Space Station is a great platform to test technologies. Not only that, but the vehicles to get there. You know, we now have Dragon, we now have Cygnus, and you know, we're looking at it as well. Can we leverage those vehicles to perform and demonstrate technology, you know, either to or from station, both from a high entry descent and landing perspective, or from a cryogenic propellant storage perspective? Can we do demonstrations, you know, in those vehicles? And so I think that's a great platform, as well as, you know, we talked about in the opening remarks about the asteroid redirect mission and our ability to demonstrate the things we need to do, you know, in deep space. Great examples for tying what we're doing together.
Sir?
Stephen Clark with Spaceflight Now. I think this question would be for John Grunsfeld. Can you talk a little bit about the decision to stop production of the ASRG flight unit and why you made that decision and what that means for future Outer Planets missions? Thanks.
Sure. The ASRGs were started quite a while ago, and it was at a time when we had a very limited supply of plutonium-238, which powers the Advanced Stirling radioisotope generator, but also our MMRTG, which is the thermocouple-based system that's powering the Curiosity rover now. Since then, we've been directed to restart the production of plutonium, working with the Department of Energy, and we have more plutonium in our science stockpile than was anticipated, such that we don't have the same need. Now, they're not quite equal units. One provides a little bit more power, but they're both in the 110 to 130 watt power range. And then we also have to look at, okay, what are the missions that are queued up that need the technology? And so we've made the decision based partly on cost and budget and also on need to stick with the MMRTGs. They need more plutonium, but with the new supply we have that, and then use our limited budget to fund missions going forward with the MMRTGs. So as far as impacts on planetary missions, it means you have to engineer your missions differently. They may weigh a little bit more. They may have a little bit higher mass. But as far as power levels, we should be able, in principle, to support nearly all of the missions that we would have with the ASRGs.
Frank?
This is Frank Mooring with Aviation Week for Mike Gazarek. You talked about getting a 20 metric ton lander down on Mars, which I think would probably involve retro rockets and supersonic speeds and that sort of thing. Can you discuss what the thinking is now as to how you would do that, get that big payload down on the surface, and what you might learn that you don't know now from MAVEN that would help you move that along?
Yeah. So we've been, largely for our successful landings on Mars, we've been relying off technology that was developed in the 1970s or earlier for Viking. Our ability to go in the 7 minutes of terror to the surface of Mars has got us to the point where we think we can, well, we've demonstrated in MSL, we can get a metric ton to the surface of Mars. We can't land on all the surface. We have to land on all the lower elevations. We need every ounce of the very thin Martian atmosphere that we can. The surface of Mars is equivalent to something like 100,000 feet here on Earth, so it's very thin. So what we have is, for the number of years, have been some studies that have been done to say, what can we do to improve our ability to slow down? And they involve hypersonic decelerators. These are inflatable hypersonic devices that were limited by the the rocket shroud and the diameter of that. So to get a bigger drag device, right, you need something that kind of fits in the rocket, but then it then expands, once you get to the Martian atmosphere. So hypersonic inflatables are one technology area we're looking at, and we demonstrated that last summer. In space technology, our first rocket launch where we inflated a 3-meter diameter hypersonic inflatable that came off a sounding rocket 300 miles above the Atlantic Ocean. We hit speeds of Mach 10 and experienced about 20 Gs as we were able to show stable performance for deceleration. We're also looking at supersonic speeds. So we think, and a number of the architecture studies show that not only hypersonic deceleration, supersonic deceleration. The parachutes we have today are limited in what range we can open them and the mass and speed for which they can be used. We're looking at different designs of supersonic speeds, and we're testing that right now at the Jet Propulsion Laboratory out in the desert of China Lake, off helicopters and rocket sleds. A fascinating sequence of taking a parachute, attaching it to a helicopter, and then a kilometer cable to a rocket sled, and then getting that sequence right where you cut it from the helicopter, ignite the rocket sled, and it's important to get that sequence right, and dragging that parachute right through the atmosphere. Incredible work. We're going to take that then to show and do it off high-altitude balloons and really building the test infrastructure we need to look at these advanced deceleration technologies. Again, it hasn't really been done since Viking. So supersonic inflatables, supersonic parachutes, hypersonic inflatables, and then also we're looking at the ability to turn on rockets at supersonic speeds. It's called supersonic retropropulsion. And so we're looking at our ability and looking at other companies who have looked at this as well. Notably, SpaceX in their last flight did some flyback of their booster. And, so we're talking to them as well to see what they learned and what data they have. So we're looking across the board at all the ways to better slow down. And we're going to advance those technologies as best we can. And this is where next demonstrations could include coming off the International Space Station, coming off some of the vehicles like Dragon and Cygnus that would allow us to efficiently demonstrate these technologies.
And lessons from Maven that might help that?
So Maven itself is, not going to the surface, but it is doing this incredible maneuver through the atmosphere. And so the data that they learn as they fly through, this very deep dips as they go through the atmosphere will provide great measurements and learning about the atmosphere of Mars. Again, we have limited data. In fact, Curiosity was the first time really we measured comprehensively how do we fly through that atmosphere. What was the heat rate through the atmosphere? Did we fly that vehicle like we predicted? Maven will also add to our ability to understand the Martian atmosphere.
Hi, Miriam Kramer with Space.com. And I'm curious, this is for anyone who'd like to answer. I'm curious, aside from the science that can be done on the surface by humans, is there a benefit to possibly colonizing Mars? And also, would the development of cislunar space and even missions to the moon be a key aspect of all of this? Thanks.
Well, before you can colonize Mars, you have to be able to get there and hopefully come back, although there are alternatives to that. I'd like to be able to go and come back, at least for the first missions, until you have a sufficient infrastructure. It's the history of exploration. Folks have gone out, long before we had an Oregon Trail with people, essentially colonizing the West Coast. Of course, there were people there already, but we had scout missions and many other things. It depends on what your long-term perspective is. If you really want to think about the long-term future of humanity, I like to say we live in a wonderfully diverse solar system. Incredible ranges of environments. From Mercury to the giant ice planets. But there's really only two places in the solar system that offer an opportunity for relatively easy living. One of which is Earth, and we're still learning how to do that. And the other really is Mars, that has an atmosphere, that has a surface with temperatures and local resources. We know Mars still has a lot of water, even though much of it may have left, to live on. And so Mars is our real opportunity to colonize another planet that's self-sustaining. There's kind of a theorem that I hope we don't prove, which is single-planet species don't survive, and that's been around for a while. I credit astronaut John Young for that. It's the first time I heard it. And so on very long time scales, we do need to find another place to live. And with the discovery of all of these exoplanets, the possibility that an Earth-like planet around a nearby star exists, that's then the next step. But I like to think about what we're going to do tomorrow, launch MAVEN, and maybe what we're going to do in the next 5 years, 10 years, 30 years. And I'm excited, as you saw on Mike Kazarik's video, the President's challenge that we send people around Mars in the 2030s and landing shortly thereafter.
Yes, sir.
James Dean with Florida Today. Question for Bill Gerstenmaier. Getting back to ISS, you've got the commercial crew RFP due out next week. I wondered if you could just discuss the significance of that event and kind of entering this final phase of development leading up to contract awards for commercial crew. And secondly, could you also please just address what is your plan for naming a permanent program manager for the commercial crew program, and is there any question about whether that position will be based here at KSC or JSC or elsewhere?
Okay, thanks. Yeah, we're in the process of getting together the final RFP, request for proposal, for the commercial crew program here in Washington. We've still got a little bit of work to do, a little bit of things to do to get that RFP ready for release next week, but it looks pretty much like it's on track. As you've seen throughout the year, we've worked very closely with industry. We've put out numerous draft RFPs. We got comments back from various providers. We got comments from the Aerospace Safety Panel. We got comments from congressional folks on the RFP, and we've tried to incorporate all those in the final version. We've also dropped several preliminary versions along the way of the request for proposal so folks could take a look at it and get ready to go actually submit their final proposals back to NASA. So again, I think we're on track for that. We've got a little bit more work to do. We'll do that over tomorrow, Monday, and then we'll get ready to release sometime on Tuesday. And then again, the responses from that request for proposal are due back in the end of January. In terms of a program manager, we're in the process of going through interviews and starting to talk to people about that. We really haven't quite started the interview process, but we'll do that. And the position will definitely stay in Florida. There's no question that the Kennedy Space Center has done a tremendous job of pulling all this stuff together. They're the lead activity or lead center for that activity. They're supported extremely well by the Johnson Space Center. The teaming between the two, between Johnson and Kennedy, has just been phenomenal to get ready for this activity and release for this proposal that's about ready to come out. So again, I think that whole activity is going extremely well. We're looking forward to that. It'll be nice to get a U.S. capability to take crew to and from station as soon as we can get that.
Okay, we'll go here and then come up to the other side of the room.
Barbara Buckner, NASA Social Media. I'm a high school teacher. My question is for Ellen. With the Cassini mission, several different teachers, we stood out and waved at Saturn in the picture that was released. My question is that the first picture which would include everyone since we've had people inhabiting the International Space Station in 2000? Because that picture would include everyone. And then my next question, kind of follow up to go along with that, does that picture pretty much will encapsulate the majority of all NASA missions except for maybe Voyager 1, Voyager 2 within that picture?
I'm actually not sure of the answer to that. Jim, I don't know if you can shout me a better answer. I mean, that image to me is so terrific. And actually, I just gave a talk a few days ago at a science meeting, and I showed the picture of Cassini looking back at the Earth, and then I put up that image because to me, the pair of those two images together is so powerful. Here we have this robotic spacecraft that we developed out just revealing the amazing things about the Saturn system, from the exotic worlds of Enceladus and Titan that I think are really going to teach us a lot and have been teaching us a lot of what are the potential limits of life in the solar system, from our studies of Saturn's rings, which have all these dynamic processes, to these cloud formations we've seen. I mean, I could keep going for hours, so I'll stop, on what we've been learning from Cassini. So that image that has Saturn in it and yet has the Earth in it, we have had the ability to travel all that way, that technology, that ability, and yet, as John and Mike both pointed out, we do that work here on Earth. We study it on Earth, we inspire kids on Earth, we've involved teachers on Cassini, which I think has been an amazing program. That is all being taken back on Earth. So to me, those two images next to each other of here's the world waving at Cassini and here's Cassini looking back at us, I just think it blows my mind. You know, I get all teared up. I just think it's amazing.
Indeed, it is quite an amazing image. It does nearly contain everything humans have ever done except for a few spacecraft, such as New Horizons, which is now much further beyond Saturn, and of course the Voyagers and the Pioneers, for which only the Voyagers are still active. But it really is a tremendously inspirational picture, and I agree with you, Ellen, just beautiful.
It's amazing what it contains, but also, I mean, since you asked what it doesn't contain, because we also have the Dawn spacecraft, which has left Vesta on its way to Ceres, and Juno and New Horizons, of course the Voyagers, but it also deliberately left out things like our stereo spacecraft around the Sun, because that's hidden behind the planet Saturn. So we really are out exploring the solar system with our robotic probes, and as I said earlier, you know, humans are already exploring Mars because all of our spacecraft have scientists and engineers who are running them. You know, the folks who are working the Curiosity rover, you know, have been doing it so long now, for over a year, that they probably think they're Martians, especially operating on Martian time when they were doing that. But we have people out, you know, exploring all over the solar system. It's really phenomenal, and I think that picture really captures it well.
And for our television audience, I want to identify Dr. Jim Green. He is the director of the Planetary Science Division at NASA headquarters. So Jim Green in the audience. Okay, we're going to take a few more questions. Going on the other side here.
Hi, Chris Haber with Rocket STEM and Spaceflight Insider. This is open for anybody at all. Could you talk a little bit about medical technology advancement that's necessary for humans to reach Mars and colonize, and such as like the nanotechnology that has the possibility of curing diabetes that's currently being done at Johnson. Things that are being done now and things that you would like to see done, and how that will impact everybody else on Earth that's not going to Mars.
If I could just jump in, one of the things, having been in this position for 2 months, one of the things I've really been trying to get up to speed on is the range of research that we're doing on the ISS, from the basic work of trying to understand how physical processes like combustion take place in microgravity, to the extensive work we're doing on trying to understand how can we have humans go beyond low Earth orbit for extended periods of time. And I thought that graphic that Bill Gerstenmaier showed earlier with the how do you move to a self-sufficient regime. And so what we're doing with plant research on the ISS, what we're doing with trying to understand the effects of humans, the exciting thing is in doing so we're learning so much, so many basic things about plants, about humans, because of the fact we evolved in a 1G environment. You put us in a 0G environment, and all of a sudden things start happening, and when that happens, you really start pushing the frontiers of science, and it's so exciting. And I think the research that's coming out and the specific things that we can do that will actually end up benefiting us here back on Earth are quite exciting.
Bill may want to join in, but I think the most salient point of all is that from the perspective of spending a 6-month increment on space station and in 2015 a 1-year increment, the human body cannot discern the difference between 6 months on space station and 6 months cruise to Mars if we're going in free fall, other than radiation. And we've made measurements with the Mars Science Laboratory on the way to Mars and now on the surface of Mars, so we understand the difference in the radiation levels, and there's still a lot of research to be done there. But by having many crew members fly on these long increments, we're learning an enormous amount about how the human body responds in this unique environment. And there's all kinds of different changes. Of course, you know about the very classical ones, the muscle atrophy, the bone loss, and those things. And I think it's incredibly important because the same things happen here on Earth. And so when we see that on orbit and we learn lessons from it, we can apply that here on Earth. There was a recent paper based on the recent results from bone and muscle loss that showed in a number of crew members very little bone degradation. And I think it's particularly interesting that the solution was diet and exercise. That's no big mystery, but we have now you talk about medical, medical device is our resistive exercise device, advanced resistive exercise device on the International Space Station. It turns out, that this message that we've all been getting, especially as Americans, get regular exercise. We now can do resistive exercise, which stresses the bones, which encourages them to rebuild the calcium matrix, is working. And you need the right nutrition. That exercise alone isn't enough. So we're learning these important lessons. I think space nutrition is one of those areas that we have to do a lot of work on to be able to go to Mars and come back, and certainly to colonize. And then the instrumentation as well, the technology end. And so I think that's why it's critically important that we do this research on station and continue it.
I'm going to wrap it up with one question.
Again, I could add a little bit also, too, if you'd like, Dwayne.
Go ahead,
This
Bill.
is
Sorry.
Gerstenmaier. I could add a little bit more, too. I'd add on what John said, that we've done a pretty good job with bone loss, and we start to understand how a combination of exercise and diet, as John described, works well for space station. But then if you think about the packaging now for a mission to Mars, our current resistive exercise device that we use on board space station is a pretty bulky device. It's a pretty large device, and is there a way we can package that device in a little smaller footprint that we could actually use on a Mars-class mission? So it's not just, overcoming these problems with human adaptation to microgravity, but it's also how do we package them in a unique way that's going to fit inside the spacecraft that we take to Mars. And then there's this natural contradiction, right, that you'd like to go do exercise to essentially stay fit from both a muscle wasting standpoint and also from a bone loss standpoint, but those involve use of calories and burning calories. That requires more food. And on a Mars mission where supplies are tight and how much food you carry is a critical consideration. Can you do plant growth, as Ellen talked about? We need to look at this kind of as more of a system standpoint, where the human is really becoming part of the spacecraft. We even see that on board space station. We recycle the urine on board space station back into drinking water. It turned out that the bone loss and the calcium loss was actually clogging up our urine processing system on board space station. So the human was actually a part of the machine. So as we go to Mars and we try to eke out every ounce of efficiency from both the machine that's taken us there and the human that we're transporting, we need to look at new, innovative, and creative ways to combine that man and machine into a system that actually operates in an extremely efficient manner that keeps the human healthy, and then also the machine that they're traveling in is also supported in a good manner. So station is a tremendous environment for us to learn about that. And as John described pretty eloquently, the things we're learning on space station have direct application to our elderly population here on the Earth. Some of the things we see, bone loss, the muscle wasting, the immune system degradation, those type of things that occur on board space station, they have direct applications to folks here on the Earth. And we can start learning from our experience on how we control them on space station to provide some innovative and creative ways for folks here on the Earth. So I think this is a tremendously challenging time, but it's also neat. As we push out to Mars, it forces us to learn new things in new ways. Station allows us to experiment with those, and then those ultimately have application back to us and here on the Earth. So it's a really nice kind of triumvirate of three pieces of pushing to Mars, using station, and then feeding those results back to people here on the Earth.
That's a question, sir, in the back.
My name's Todd Mesereau. I'm here for the Travel Channel, and it's my first launch. I'm really excited to be here and see Maven on its 10-month journey. It's a long trip. Why is a Travel Channel here? Some people say. Well, Maven's traveling, and Maven's going to Mars, and Mike and other people in this room probably want to go to Mars too. As a taxpayer, I think NASA is an astonishing return on bang for buck. I mean, it's remarkable, everything that's been done on such a tiny budget. And I guess it feels like we're in this transition phase with all these private ventures into space, and people think, oh yeah, Richard Branson's going to send people up into space. It's low Earth orbit. It's just a couple of minutes of weightlessness. I guess my question is there any sort of long-term marketing plan to capture the excitement of what NASA is doing and sort of translate it into better funding? Because it seems like this comes up all the time. And reaching outside of this room and outside of this people, in my mind, is NASA's biggest challenge, to secure enough long-term funding to make it, allow us to get to Mars sooner. The last thing that, in my mind, that captured the public imagination was Chris Hadfield singing, Ground Control to Major Tom. That reached outside of all these people here who love space. Is there any plan? I know there's, there's legal restrictions on lobbying and things that NASA can do, but is there any sort of overall marketing plan to communicate the great excitement of everything that NASA does?
John?
Okay, so
Well done, Bill.
okay, so now we know why the Travel Channel is here, and so let me just fire a question right back. Best places to eat in Cocoa Beach? No, sorry. Anyway, I think it's really cool that Travel Channel is well represented here, and that actually all of you are here. We don't, marketing is something that NASA, doesn't really do, but we do communicate and we do educate, and I think that's our marketing plan. We queue up amazing missions, and we do it with our partners. We do it for MAVEN with University of Colorado Boulder, LASP, and all of the partners. Mars Curiosity landing. Keep in mind, we reached millions and millions of people, the big screens in Times Square, libraries, museums, all the news channels above the fold. And we do that by queuing up really exciting missions, whether it's a science mission or a human spaceflight mission, activities on the International Space Station, our technology demonstrations. That's our return to the country. And because they're engaging and exciting, and especially when we go to Mars, I think that's the marketing plan, if you will, is to continue to provide great returns. The question on budget is one that, we do as much as we can with the budget that we get, and that's a much more complicated question. But I do just want to end with a couple of things. Yesterday at NASA, the social event that I did, and I'm sure it was a similar experience for others, I asked the assembled group who wants to go to Mars. And this isn't something I just did yesterday. I ask every time I address, a group of kids. I was in Nepal and Thailand the last 2 weeks, and I asked folks there, culturally very different, and I always get the same result. A lot of hands go up. And I'll do it now to all of you here from the media and the press. How many of you would like to go to Mars? And lots of hands go up. Frank? No? That's okay. But you'll report on it.
You'll report on it.
And so I'm just really excited for tomorrow's MAVEN launch, for our other Mars missions. And just to remind everyone, the Curiosity landing was a real nail-biter. It was exciting. But now we're roving on the surface. We're trying to understand, look for signs of, past, organic compounds. And we've already made enormous discoveries here that the results just keep on coming out, and I encourage you to keep following it. So tomorrow we'll launch MAVEN. In about 10 months, start looking for the science return, because I think we're going to learn a lot. We're going to answer we're going to unravel some mysteries of the universe, at least with respect to Mars. And so I hope you will continue your travels with us at NASA as we get to Mars.
So with that, ladies and gentlemen, let me thank Bill for joining us in Washington, John, Mike, and Ellen. Ladies and gentlemen, the message is very clear. And you heard from these folks. Human mission to Mars in the 2030s, there's real progress being made, thanks to these folks and an incredible team. The stage is set. Launch coverage begins tomorrow at 11 a.m. at NASA Television. Let's go back to Mars, folks. We'll see you tomorrow. Have a great Sunday. Well, good morning. My name is Dwayne Brown from NASA's Office of Communications at NASA headquarters in Washington. Thanks for joining us. In this last briefing for today, NASA's senior leadership will give their views and comments on how MAVEN and other NASA mission and activities in the agency's exploration portfolio are paving the path toward a human mission to Mars in the 2030s. We'll have brief presentations and remarks from our participants. Then we'll open it up for questions here at the Kennedy Space Center. As always, you can get updates on the MAVEN mission online at www.nasa.gov/MAVEN. And of course, join the conversation on social media. And when it comes to Mars, there's always a lot of conversation on Twitter, Facebook, and other social media venues. Let me start by introducing our participants, and I'll start here at the Kennedy Space Center. First to my left, someone who's very familiar with the Kennedy Space Center, 5-time flown Space Shuttle astronaut, astrophysicist, and the Associate Administrator for NASA's Science Mission Directorate.
Those resources be used as a tool for human exploration. So again, science is kind of proving the way or pushing the way forward. We'll take the data from the scientific investigations, use those on the human side, as well as understanding the basic science activities that are occurring around Mars. So again, I think I'm looking very forward to this MAVEN mission. The data will be important to us on human spaceflight, and it also fits well with the science activities going forward. So with that, I'll turn it over to John down at the Kennedy Space Center, and he'll continue on with the discussion of the MAVEN and the science activities. John?
Thanks, Bill. So, of course, we're here for the MAVEN launch, and I'm excited to see it go off tomorrow, hopefully not any later than that. And, you know, MAVEN is a science mission, but none of our missions are really can be characterized as just science missions. All of our missions are human missions in the sense that, you know, it's the science teams that are going to be analyzing the data. And, you know, if you ask, you know, Bruce or any of the team, they're going to Mars tomorrow. And I'm very excited about that. As a human spaceflight flyer, I would love to be on board with MAVEN. In fact, I drove by Complex 41 to see if there's any...
We talk about kind of as we push humans beyond low Earth orbit, really out into deep space. So, you know, where we are today with the International Space Station, we have a crew of 6 on board the space station doing a lot of research that benefits us here on the Earth, but they're also doing a lot of activities that are really preparing us to go beyond low Earth orbit. You know, just the fact that we have humans there for an extended period of time, we're understanding how the human body reacts in the microgravity environment. So on missions on the way to Mars and of that duration, we need to know how the human body actually adapts to that environment, and are there any unique special needs that we need to take care of the crew. So we're understanding how the crew operates and lives and works in that environment on board space station. We're also using the space station to develop technology that's needed to last a long duration. We need systems that are tremendously reliable, require low maintenance, and ready to move those kind of distances as we start breaking the tie with the home planet. In that middle region, we talk about kind of the proving ground, and what that is that's moving out into cislunar space. It's the asteroid redirect mission. It's those kind of activities where we're starting to break the tie from the home planet, from Earth, but yet we still have the ability to get back in several days to the Earth if something goes wrong, or if we have equipment that needs some different activities. We also need to operate or learn how to operate from an orbital mechanics standpoint in that region. And then finally, when we get out distances as far as Mars, we really need to break that tie back to Earth. So at that point, we need to be independent from the Earth. We need to understand how to use the resources of the environment where we are, where we're at. We need to carry with us all the supplies we need from Earth and the ability to essentially use in situ resources, or essentially live off the land in those remote locations. The MAVEN mission, which we're all here for today, or you're all there for today down at Kennedy, I wish I could be there with you, but I'm not. I'm here in Washington. But the MAVEN mission will provide some interesting information for the scientists, and John will talk about that, but it's also good information for us kind of on the human spaceflight front to understand how the atmosphere of Mars is put together, what the upper atmosphere is like, what the mid-level atmosphere is like will be important as we look at entry, descent, and landing into the Martian atmosphere with larger spacecraft than we've done before, the kind of spacecraft that will be needed for human missions. We'll also understand what resources are available in the atmosphere, and can some of...
John Grunsfeld. The Associate Administrator for Space Technology Mission Directorate, Michael Gazurek, and a footnote here, the agency, realizing the importance of space technology, it elevated the space technology program into a new directorate in February of this year. Michael Gazurek, Associate Administrator. and NASA's new chief scientist, starting in the position August 25th, Ellen Stofan, the principal advisor on the agency's science programs and science-related strategic planning and investments. And joining us from our NASA studio in Washington, D.C. at headquarters, the Associate Administrator for NASA's Human Exploration and Operations Directorate, William Gerstenmaier. And with his portfolio with ISS, Orion, SLS, and commercial, a lot of good things are happening on that front. And to hear from him and the things and the synergy between science and humans, I'll toss it to Bill in Washington. Bill, the floor is yours.
Okay, thank you, Dwayne. Can I have my first slide, please? On this graph,